ever heard of the normal distribution? And did you know that it looks like this? You probably have, but how do you know that your data follows this distribution? If this is the histogram of your CTQ, does it follow the normal distribution? In this video, I will teach you how to answer this question. We will study a tool called the probability plot to find the correct distribution for your data. But why do you want to know which distribution fits to your data? Well, you will need that information for many statistical tools such as the empirical CDF, ANOVA or regression, which are all coming up in the next videos. So, let's have a look at a probability plot. For that, we first go back to a call center, where a project is started to improve the total handling time, which is the total time that an employee is busy with answering a call. The CTQ is therefore total handling time. And you gathered data about this process, and one of the variables is the total handling time. This is what it looks like. In this video, I will show you how to fit a distribution to this data. But first, let me show you the distributions that we will consider. You saw them already in the video on normal, Weibull and log normal distributions. There are many different probability distributions. In a Lean Six Sigma project, you will often only encounter these three though, so that makes life a lot easier. You will see the normal, the Weibull or the log normal distribution. Let's return to our example of the total handling time. From the shape of the histogram, we can already see that the data is not normally distributed. But is it then Weibull or log normally distributed? The tool we will use to find the best fitting distribution is called the probability plot. Let's take a look at how to make one with Minitab. So, pause the video, load your data before you continue. I only copied the variable THT or total handling time into Minitab, but you can have the rest there too, doesn't matter. For the probability plot, we go to Graph, and then you find the probability plot over here. Select. We have a single variable, so we select single and OK. Well, we want to make a probability plot for total handling time. That's it. OK, let's have a look. This is a probability plot for the normal distribution. Let's make one for the log normal and the Weibull before we interpret the graph. So we go back to Graph, you go back to probability plot, single, OK. And we still have total handling time there, but now we go to distribution. And instead of having the default for normal, we select log normal. OK, OK. And we have a second probability plot for the log normal distribution. Let's make another one. An easier way to go back is with this Edit Last Dialog button, and you get there straight away. Go to Distribution and select the Weibull distribution here. OK, OK. And this is our third probability plot. Well, let's have a look at these outputs. This is the probability plot. On the horizontal axis you see the data. To check if the distribution fits well, we have to look if the measurements, the dots, are on a straight line, and as much as possible between the two outside lines. The middle line represents the normal distribution. We see here that the normal distribution is a poor fit for the total handling time. Let's take a look at another probability plot. Here the data is compared to the Weibull distribution. The data is not in between the lines, hence it does not fit well. So, let's take a look at the log normal distribution. Here we see that the data lie in between the red lines, so the data is log normally distributed. If you compare all three graphs, you can conclude that the log normal distribution fits best to your data of THT. As a second check, you can compare the AD values. This is the Anderson-Darling statistic. It measures the distance between your data and the theoretical distribution, such as the normal, Weibull or log normal distribution. The lower the value, the better the fit. So we select the distribution with the lowest AD value. In this case, The log normal distribution has the lowest AD value and therefore fits the data best. Remember this diagram? The probability plot is a tool to determine which distribution you should use to model the population. Apart from this, you can also use the probability plot to spot data anomalies. So, concluding, the probability plot is a powerful tool to determine which distribution fits best, and it can be used to spot these anomalies. Let's have a look at some common situations. This probability plot clearly shows outliers. It can also help to detect bimodality. In that case, you will see an S shape, representing the two distributions. Probability plots that have small stacks of data really show that the data have been rounded off. You should then focus on the midpoints of the data stacks. In this example, we can conclude that the data is approximately normally distributed, but also rounded off. In summary, a probability plot can be used to find a theoretical distribution that fits best to your data. If many data points deviate from a straight line and do not fall between the two outside lines, then we call it a poor fit. If the data lies more or less on the straight line and many of the points lie between the two outside lines, we call it a good fit.